Hi class, on to stationary fronts. So stationary front, as the name implies, is a front that doesn't move very much. It is represented by an alternating red and blue line. So the blue line basically is broken up cold front, and it points into the direction that cold air wants to move. And alternating between that are red lines with red semicircles that point in the direction that maritime tropical air, warm moist air, wants to move. And so we have on either side of the front here, we have cold, high pressures, and we know that around high pressures that air flows clockwise and outward. All right, so if we draw in the winds associated with high pressures, all right, notice that we have convergence taking place. To the north of the stationary front, we've got air coming in typically from a northeast wind. And to the south of a stationary front, we typically have winds coming in from the south. Okay, and probably what I should have first done. So this is going to be continental polar air to the north of the front, and to the south of the stationary front, this is going to be maritime tropical air. So we have air masses of contrasting property. So this continental polar air is going to be cooler and drier and less dense. More dense. And this maritime tropical air is going to be warmer, moister, and if it's warmer and moister, it's going to be less dense. All right, so we've got continental polar air represented by this high pressure, circulation clockwise and outward, cooler, drier, more dense air, and so typically the air to the north of a stationary front is going to be out of the northeast. We have a maritime tropical air mass represented by another high pressure, circulation clockwise and outward, warmer, moisture, less dense air with a southerly flow. All right, so if we just follow this along, we've got convergence taking place, and also frontal lifting. So we have two methods of causing the air to rise along a stationary front. And so that's just what's going to happen, is the air is going to rise, and the clouds and precipitation associated with the stationary front are pretty similar to that associated with a warm front. So any clouds that take place are typically going to be to the north of a stationary front, and that's where the precipitation would also occur, would be out what we call ahead or to the north of a stationary front. The stationary fronts kind of drive meteorologists crazy, because even though they're called stationary fronts, they might wobble a little bit. If they last for 2 or 3 days, maybe it moves one day 50 to 100 miles to the north, and the next day it moves 50 or 100 miles to the south. And it just, if you're trying to forecast for an area that is in close proximity to a stationary front, it makes it very difficult to try to predict the weather. So it does drive meteorologists a little bit crazy. So that's stationary fronts. And again, the precipitation is very similar to that associated with a warm front. It's going to be light to moderate precipitation for an extended period of time, because this thing's not moving very much. Now, even though I say light to moderate precipitation, again, you can, under the right circumstances, get some severe weather associated with stationary fronts if the conditions are right. So generally speaking, light to moderate for an extended period of time is the type of precipitation you have. But under the right conditions, you can get some pretty good severe weather out of stationary fronts too. All right, take care.